Variation. This is a really practical use of algebra and mathematics, so I think it's worth some time taking a look at some good examples. We're going to look at three different types of variation here, but all of them, all the problems that we deal with are pretty much going to be solved using the exact same three steps. Okay, there's only one little minor difference in each of them. So if we can get those steps down, we should be able to master this topic. The three types of variation we're going to look at are direct variation, inverse variation, and joint variation. So direct just means that if one variable goes up, the other goes up. They do the same thing all the time. And we represent that with the equation y equals kx. Now this k is a constant of variation, and that's going to be different for all the different problems we're working with, and we're going to actually usually have to solve for that. Okay, so the y and the x are my variables, and they're directly across from one another. In inverse variation, well, that would mean that one variable goes up, the other's going to do the opposite and go down. Okay, so to represent that, we would do it y equals k over x. So one is inverted from the other. And the last type here is joint variation, and that is direct variation if I have more than one variable. All right, so y equals kxw. It's direct, so it's everything on the same level, directly across from one another. We just use one constant, and we have the two variables x and w. Let's take a look at some direct examples. Distance required to stop a car varies directly as the square of the speed. And we're going to suppose that it takes 200 feet to stop at 60 miles per hour. How long would it take at 80 miles per hour? Okay, so let's call distance d. Varies as soon as I see that word, I know that's my equal sign, directly as the square of the speed. So square of the speed, we're going to call that s squared. So the first step is to come up with a variable equation. D equals ks squared. And why is it all directly across? Because it says varies directly. Step 2 is take this information that they've given us and find k. So 200 feet is my d, my speed is s, 60, so 60 squared. Multiply that out, divide, and k equals 1/18th. Now I'm going to say this is really important. You don't want to round at this step, all right? Just go ahead and simplify your fraction. Use your calculator if you need to. You could do 200 divided by 3600, okay? And then it will, going to give you a decimal, of course, but we can change that to a fraction by going to math and then fraction, and then I get my 1/18th. So I get the exact answer. Now third step is plug in so that you can solve and answer the question. The distance is what we're looking for. How long will it take to stop at 80 miles per hour? So we're going to put in our 80 here for my s, work it out. Now I can round and get approximately 356 feet. Let's take a look at one more, a direct example. Fidelity Investment Magazine, Investment Vision Magazine, says that the average allowance A varies directly, so there's my equals, as the grade level G. So first step, A is going to be equal to KG, directly across from one another. It's known that the average allowance of a fifth grader, so that's our G, is 588. That would be our A. So we plug those into that formula. That allows us to solve for K. Now here I didn't even bother getting a simplified number. I can use 5.88 over 5. You know, it's an in-between step. It's not my final answer. I don't have to worry about it looking pretty. So I'm going to take that and plug that in so I know that A is equal to this 5.88 divided by 5 times whatever G is. Third step, answer the question. What is the average allowance of a ninth grader? So they're telling me the G. I plug that in, just like that, 588 divided by 5 times 9, and I come up with 1058.